Welcome to Educator.com. In the recent lessons, we've been working with rational expressions. Today, we're going to talk about solving rational equations. A rational equation is an equation that contains rational expressions. If each side of an equation contains only a single rational expression, you can solve the equation by cross multiplication. This is actually the simplest case and the easiest to work with. So think about in earlier lessons when we talked about proportions. For example, if I had a proportion such as this. Recall that you could solve that by cross multiplication. You multiplied the denominator of one of these fractions by the numerator of the other and do the same on the other side. The result would be 4 times 1 equals x times 2, or 4 equals 2x. From there, it's easy to solve for x. X equals 2. This is the same idea, except now the fractions that we're talking about are actually rational expressions. For example, if you're given 3 over x minus 5 equals x minus 4 over x plus 1. You can solve by cross multiplication. Multiplying this numerator and this denominator and this numerator and this denominator. Okay, so that gives me 3 times x plus 1 equals x minus 4 times x minus 5. Now, once I've done that, then I have something that I can work with and solve. First, multiplying out 3x plus 3 equals x squared. Outer term is negative 5x. Inner term is negative 4x. That's negative 9x plus 20. Negative 4 times negative 5 is 20. Simplifying a little bit more. So this is x squared. I'm going to move these two terms to the right, so I subtract a negative 3 from both sides and subtract a 3 from both sides. That will move these terms to the right side. Equals x squared minus 9x plus negative 3x is negative 12x. 20 minus 3 is negative 17. Just rewriting that so that we have the variables on the left. I end up with a quadratic equation, and you could try to solve this by factoring, but probably you'll have to use the quadratic formula. That'd be the easiest way. But in any case, we just started out with a rational equation that had a single rational expression on either side and cross-multiplied, and then we can go ahead and solve using methods previously learned. That's one situation. In other situations, you have additional terms, you have more than just a single rational expression on either side of the equation. Any rational expression can be solved using this method. The method that I'm going to show you that allows you to solve any rational equation is multiplying both sides of the equation by the LCM of the denominators of all the rational expressions in the equation. This will allow you to get rid of the fractions. Last time we got rid of the fractions by cross-multiplying in the previous slide. Now you're going to have to use a slightly different technique if you don't just have a single rational expression on each side of the equation. For example, y over y minus 1 plus 3y over y plus 2 equals 2. Well, I could certainly move one of these rational expressions through subtracting it from both sides. I could move one over to the right, but if I did that, it wouldn't help me because I still have this 2. If I subtracted both sides by y over y minus 1, I'd end up on this side with 2 minus y over y minus 1. So I still couldn't cross multiply. In this case, I need to multiply both sides by the LCM of the denominators of all the rational expressions. So let's look at the two denominators. I have y minus 1 and y plus 2. So I need to multiply by y minus 1 times y plus 2. And I need to do that on both sides. So let's go ahead and do that. Y minus 1 times y plus 2. And I'm going to multiply all of that times this. On the right side, I have 2 times y minus 1, y plus 2. Okay, using the distributive property, I could rewrite this as y minus 1, y plus 2 times the first term, which is y over y minus 1, plus y minus 1, y plus 2 times the second term, 3y over y plus 2, equals 2y minus 1, y plus 2. What happens is some of the terms will cancel out, so I see that this cancels. That leaves me with y times y plus 2, but the fraction's gone. By multiplying by all these factors, I eliminate the fractions in the ration, so the rational expressions are eliminated. Okay, over here I have y plus 2 as a factor that can be canceled out. This is y minus 1 times 3y equals 2 times y minus 1 times y plus 2. What you're left with is definitely going to require some work in order to solve. You need to multiply all this out. You'll end up with a quadratic equation. You can solve that using one of the techniques, such as the quadratic formula. Then you can solve for y. However, what we accomplished here is the first step, which is to get this set up so that it can be solved by multiplying both sides of the equation by the LCM. Rational equations can be used to solve a certain set of problems called work problems. And in these problems, you have a person or a machine doing work at a certain rate, and often then they'll mention another person or another machine is doing work at a different rate, and ask you something such as, if 2 people were working together, how quickly could the job be accomplished? For example, let's say it takes Jason 4 hours to complete a history project. And let's say it takes Ella 5 hours to complete the history project. So if it's going to take Jason 4 hours and it's going to take Ella 5 hours, you might be asked, how long will it take to complete the project if they work together? Okay, so you need to think this out. If Jason works at a rate that allows him to complete the project in 4 hours, that means that in 1 hour, he will complete 1/4 of the project. So he does 1/4 of the project in 1 hour. 2 hours, he'll have half. 3 hours, 3/4. In 4 hours, the whole project will be done. 4 hours to complete the project. That means in 1 hour, he'll be done with 1/4 of the project. Ella takes 5 hours to complete the project. That means that in 1 hour, she will complete 1/5 of the project. Now, if they work together, we have Jason's time is 4 hours, Ella's time is 5 hours. Let's call X equals the time to complete the project together. So some amount of time, X, it's going to be shorter than the quickest person's time. Jason only takes 4 hours. That means if Ella's helping him out, it's definitely going to be quicker than 4 hours, maybe 3 hours or maybe less to get the project done. So X represents this time, which is unknown, that they could complete the project in if they're working together. That means that together, in 1 hour, they will complete 1 over X of the project. X could be 3, it might be a third of the project. I don't know that yet. It's some unknown amount of time, X, that it takes them to complete the project together. Well, in 1 hour, they will complete 1 over X of the project. You could then write an equation using this. That means that Jason working together, that Jason's time plus Ella would equal their time together. Per hour. So in an hour, Jason can do a quarter of the project. In an hour, Ella can do a fifth of the project. Together, in an hour, they can do 1 over X of the project. Now, this is where the rational expressions come in. What I need to do is use the technique we just discussed and multiply both sides of the equation by the LCM of the denominator of all the fractions and the rational expressions in order to get rid of the fractions. So I'm going to need to multiply by 4 times 5 times X. So over here, I multiply 4 times 5 times X times 1/4 plus 4 times 5 times X times 1/5 equals 1 over X times 4 times 5 times X. Looking, I see that the 4's cancel out, so this is going to leave me with 5X plus, for the second term, the 5's cancel out, so that's going to be 4X equals, the X's cancel out here, 4 times 5 is 20. Now I can solve for X. This is 9X equals 20, or X equals 20 over 9, which equals 2 and 2 9 hours. And you always want to check and make sure it makes sense. Well, if Jason can get it done by himself in 4 hours, if Ella's helping out, it's going to be significantly shorter. So if these two work together in 2 and 2 9 hours, they'll have the project completed. Now, one thing that occurs or can occur with using the multiplying by the LCM method to solve rational equations is that you can end up with extraneous solutions. Recall that when we were working with radical equations, equations involving radicals, we sometimes solved by squaring both sides. When we squared both sides, it created an equation that was new and slightly different than the original. The result was that we sometimes came up with extraneous solutions. They were solutions to the new equation, but they weren't solutions to the original equation. When we were working with those radical equations, that meant that when we used that technique of squaring both sides to solve an equation that way, we had to check all the solutions back in the original equation. The same situation exists here. When you multiply by the LCM, you create an equation that is slightly different than the original equation. And the result is that the solutions you can come up with, some or all, may actually not be solutions to the original equations. Instead, they're extraneous solutions. So you need to check all solutions when you use this LCM method. Let's explore this a little bit more. If you have 1 over y minus 1 plus 1 over y plus 2 equals 1, and you're asked to solve that, well, you can't use the cross multiplication method because you have this 1 here. You don't just have a rational expression on either side of the equation. So you're going to use the LCM method where you're going to multiply by y minus 1 times y plus 2. You're going to multiply both sides by that. So let's go ahead and do that. Y minus 1 times y plus 2 times 1 over y minus 1 plus y minus 1 times y plus 2 times 1 over y plus 2 equals 1 times y minus 1, y plus 2. Right here, the y minus 1's cancel out to give me y plus 2. So I got rid of the fraction, which is what I was trying to accomplish. Plus, right here, cancels out. That gives me y minus 1. And on this side, I multiply out to get y squared. And this is plus 2y minus y. So that's going to give me plus y. Minus 1 times 2 is negative 2. Okay, over here, simplify a little more. I get 2y, y plus y. 2 minus 1 is 1, plus 1, equals y squared plus y minus 2. Well, let's say I continue on and solve these. And I'm going to end up with a quadratic equation, and I'm going to end up with either a double root, so just one unique solution, or I could end up with 2 solutions, or I could end up with no solutions, but let's say I get 2 solutions. And I'm not going to solve this all out and figure out what the solutions are, but let's just say, assume one of the solutions is y equals 1. Now, let me go ahead and put that back into the original equation and see what happens. The original equation, that would give me y minus 1. So if I substitute in 1, this is what I'm going to get. Plus 1 over y plus 2 equals 1. So substitute 1 in here as well. Okay. Look what happens here. I end up with 1 over 0. That is an undefined expression. Therefore, you cannot solve this. That's undefined. It's not allowed. So this would be an extraneous solution. Extraneous solutions are ones that if you went back up to the original equation, you'd end up with a 0 in the denominator. Y equals negative 2 would also be an extraneous solution if we came up with that. And you can end up with 2 valid solutions, 1 valid solution, no valid solutions. You just have to go and check them back with the original. So the problem arises because this originally here we have fractions. We multiplied by something to get a new equation that doesn't have fractions in it. And so we get some solutions that might not work in this original equation where there is a fraction. So when you use this LCM method, you need to figure out if the solutions are valid or not. Okay, in this first example, we're back to the simple case we discussed in the beginning, where you have a rational expression, one single rational expression on either side of the equation, which means that you can solve simply by cross-multiplying. So I'm going to cross-multiply. And that's going to give me x times x minus 1 equals x minus 2 times x plus 3. Go ahead and multiply that out to get x squared minus x equals, first term is x squared, plus 3x, inner is minus 2x, and last is negative 6. Further simplify, this gives me x squared minus x equals x squared. 3x minus 2x, that gives me x minus 6. Okay, I can subtract the x squared and x squared from both sides. And what's going to happen is these x squareds will cancel out. So that's going to give me negative x. These dropped out, equals, this is dropping out, x minus 6. Okay, so I'm going to add x to, I'm going to actually subtract x from both sides. So subtracting an x from the left and the right, I'm going to get negative 2x equals negative 6. Divide both sides by negative 2 is going to give me x equals 3. And I did not use the LCM method, so I don't actually have to go back, but I can go back and double check if I want, and I'll see that 3 is, and then I have 3 minus 2 equals 3 plus 3, so I'm substituting 3 wherever there's an x. That's going to give me 3 over 1 equals 6 over 3. 3 equals 3. This is a valid solution. Okay, in the second example, I'm going to need to use the LCM method, because I don't just have a single rational expression on left and the single rational expression on the right. I've also got this 1 right here. So the LCM that I'm going to multiply by is going to be 2x minus 1, x minus 3. And I'm going to need to check my solutions at the end because I may end up with some extraneous solutions. Okay, so multiplying 2x minus 1, x minus 3 times this first expression. And I'm doing this in order to get rid of the fractions. And I need to multiply both sides of the equation by the same thing. Okay. Go ahead and see what cancels out. This is going to leave me with x minus 3 times x. Here I've got x minus 3 is canceling. I get 2x times 2x minus 1. And on the right, it's just 2x minus 1 times x minus 3. I'm going to go ahead and work this out to get x squared minus 3x plus 4x squared. 2x minus 1 is minus 2x equals 2x times x is 2x squared. Outer terms, that is negative 6x. Inner terms, negative x, so that's negative 7x. That's negative 6x plus negative x. And then the last terms, plus 3. Okay, doing some simplification here. I've got x squared and 4x squared, that's 5x squared, minus 3x minus 2x is going to give me negative 5x equals 2x squared minus 7x plus 3. I'm going to continue on because I need to solve this, so I want to get it equal to 0 and have a quadratic equation that I can work with. Subtracting 2x squared from both sides will give me 3x squared. Adding 7x to both sides will give me plus 2x. Subtract 3 from both sides. Okay? So all I did is get all the terms on the left. Now I have a quadratic equation. And you can try to factor this out, but it turns out it actually doesn't work where you're going to get integers as factors. So the next way to proceed would be using the quadratic formula. Just to remind you, the quadratic formula, if you're solving for x in a quadratic equation, x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Now, this is written in standard form, so I got it into standard form so that I can say, okay, a equals 3, b equals 2, and c equals negative 3. And what I need to do is substitute. So x equals negative b, so that's going to be negative 2, plus or minus the square root of b squared, and b is 2, so that's 2 squared, minus 4 times a, which is 3, times c, which is negative 3. All of that is divided by 2 times a, which is 3. Okay, this gives me x equals negative 2 plus or minus the square root of 4 minus 4 times 3 is 12 times negative 3 is negative 36. 2 times 3 is 6. Okay, let's continue on right up here. So I'll rewrite this. X equals negative 2 plus or minus. I can do some simplifying in here. 4 minus negative 36. Well, that's really 4 plus 36, because I have a negative and a negative. So I have a positive. 4 plus 36 all over 6. I continue on. X equals negative 2 plus or minus 4 plus 36 is 40. Okay. I can simplify this a bit because I do have a perfect square under here. This can be rewritten as 10 times 4. And since 4 is a perfect square, I can take the square root of that and get x equals negative 2 plus or minus 2. So I've taken the square root of that. Radical 10 over 6. I also have a common factor of 2 here. So I could factor a 2 out from here, and I can cancel out that common factor. So then I'm going to end up with negative 1 plus or minus the square root of 10 over 3. Okay. And that was by factoring out the common factor of 2. So this is as simple as I can get this right now, but let's go back now and think about extraneous solutions. Recall that extraneous solutions are ones that would make the denominator 0. So if I'm thinking about extraneous solutions, I can say, okay, 2x minus 1 equals 0. I don't want it to equal to 0. But if I solve for x, if x were to equal 1/2, this would come out to 0. That is an extraneous solution. If I had x minus 3 equals 0, I could just solve and say x equals 3. Either one of these would give me extraneous solutions. Well, if you worked this out, you would find that this does not come out to, this isn't even a rational number. If you figured this out, you would find out that it did not come out to x equals 3, nor does it come out to x equals 1/2. Therefore, this gives you the two valid solutions. One of the valid solutions is that x is going to equal negative 1 plus the square root of 10. The other valid solution is that x is going to equal negative 1 minus the square root of 10, and both of those divided by 3. Okay? So although I didn't go back and find the exact value and plug it in, I know that just looking at this, it's not going to come out to either of the x values that will make this invalid or extraneous. Okay, the third example is a work problem. Here, Jack paints a room in 6 hours. Jim paints the same room in 4 hours. If they work together, how long does it take them to paint the room? All right, so in 1 hour, Jack can paint 1/6 of the room. In 1 hour, Jim can paint 1/4 of the room. Now, we don't know how, they're asking us how long it takes them to paint the room. And we're just going to say x equals the time to paint the room together. I know that it's going to be shorter than 4 hours, because even if Jim's by himself, he can get it done in 4 hours. So with Jack helping, probably be 3 hours or less. Sometime x. I don't know what that is. In 1 hour, Jack and Jim together can paint 1/x of the room. This allows me to write an equation. So in an hour, Jack can paint 1/6, Jim can paint 1/4, and together they can paint 1/x. Now I need to solve for x. In order to do that, I'm going to multiply both sides of the equation by the LCM, which is 6 times 4 times x. So 6 times 4 times x times 1/6 plus 1/4 times 6 times 4 times x equals 1/x times 6 times 4 times x. Let's see what we can cancel. That gives me 4x, so I'm getting rid of my fractions. That's why I multiplied by this. The x's cancel to give 6x. And here the 4's cancel here to give 6x. Here the x's cancel to give me 24, 6 times 4. Okay, I go ahead and add this up, and this is going to give me let's see, 10x equals 24. And that's going to give me x equals 24 divided by 10. So x equals 24 divided by 10. So x equals, we could rewrite this as 12/5, which equals 2 2/5 hours. Okay, so that makes sense. Jim paints the room in 4 hours, and if Jack is helping, it's going to significantly cut down the amount of time that it takes to do. So both of them working together take 2 2/5 hours. So remember, Jack working alone can paint 1/6 of the room. Jim can paint 1/4 of the room. Together, they can paint 1/x of the room. Therefore, 1/6 plus 1/4 equals the amount of the room that they can paint together in 1 hour. I multiplied by the LCM to get 4x plus 6x equals 24. 10x equals 24. That's 24/10, or 12/5, which is 2 2/5 hours. Okay, in this last example, again, we have a rational equation that needs to be solved by multiplying both sides by the LCM. Well, I need to figure out the LCM, and I need to factor. So I have the first one, the denominator, is x minus 1. So that's just x minus 1. The other denominator is x squared minus 1. The difference of two squares equals x minus 1, x plus 1. So the LCM is going to be x minus 1. I already have that accounted for here, but I have an x plus 1 that's unaccounted for. So this is the LCM. In this case, the LCM is actually equal to this second denominator. So I don't really have to do anything with that. So let's go ahead and look at what happens when I multiply by the LCM. X minus 1, x plus 1, times 2x over x minus 1. Now I'll go ahead and write this out, that I am actually, I could multiply by this, write it all out. Well, I do have to cancel out the bottom, but the LCM is actually the same. Okay, this is x minus 1, x plus 1, but I know that this all cancels because these are the same, equals x plus 1 times x minus 1. Okay, let's see what happens. The x minus 1's cancel. This is going to give me, I'm going to be left with 2x times x plus 1. Here, they all cancel. So I know that since everything was canceling, I'm just going to have an x minus 5 left. But it's good to write it out so you can see exactly what's happening. X plus 1, x minus 1. Now I just need to simplify. And this is 2x times x is 2x squared. 2x times 1 is 2x plus x minus 5. On this side, I'm going to get x squared. Then the outer term is negative 1. The inner term is, the outer term is negative x. X times negative 1 is negative x. The inner term is x, cancels out. Negative x plus x cancels out. The last term, 1 times negative 1 is negative 1. Okay, now do some more simplifying. I have 2x squared. 2x plus x is 3x minus 5 equals x squared minus 1. Subtract x squared from both sides. That's going to give me x squared plus 3x minus 5 equals 1. Subtract 1 from both sides. X squared plus 3x minus 6 actually that's a negative 1. So add 1 to both sides. Correction, add 1 to both sides equals 0. Okay, so one side canceled out. I ended up with this. Multiplied it out. Then simplified. So I got 2x squared plus 2x plus x is 3x minus 5 equals x squared minus 1. This gave me, if I subtracted x squared from both sides, x squared plus 3x minus 5 equals negative 1. add 1 to both sides to get x squared plus 3x minus 4. And I'm going to go ahead and try to solve this by factoring. Since this is negative, I know I've got to have a positive and a negative. And I want it to have factors of 4 that add up to 3x. So that's going to be 1 and 4. And it's positive 3x, so I'm going to make the 4 the larger number, the positive, and the 1 the negative. Checking this, x squared, right? Outer term's negative x plus 4x is going to give me 3x. 4x minus x is 3x. Last term is negative 4. Okay, using the zero product property, I'm going to get x plus 4 equals 0, and x minus 1 equals 0. Therefore, x equals negative 4, and x equals 1. Now, I need to check and see if I have any extraneous solutions. Let's start with x equals negative 1. And rewrite this down here. All right, if I let x equal 1, I can see what's going to happen already. 2x over 1 minus 1. Just looking at this first term, that's 2x over 0. The same thing's actually going to happen here. That is not allowed. So this is an extraneous solution. Okay? Now, let's look at x equals negative 4. You can see that if x equals negative 4, this denominator is going to be negative 5, which is fine. And if this is negative 4, this is going to be 16 minus 1, and that's 15. That's fine as well. In fact, we could substitute all of this back in, just to look, for negative 4, and see that it's 2 times negative 4 over negative 4 times minus 1, plus negative 4 minus 5 over negative 4 squared minus 1 equals 1. Solving this out, you will find that this gives you 1 on the left equals 1. So this negative 4 is a valid solution. So my only solution here is x equals negative 4. I'm throwing out x equals negative 1. That is not a valid solution. So because I used the LCM method to solve this, to get rid of the fractions, I ended up with a new equation. When I multiplied by the LCM, I actually created this equation, which is slightly different than the original. The fractions are gone. The result is that I ended up with a solution that is not a valid solution because x equals 1 would result in 0 in the denominator, which is undefined in math. So we can't use that as a solution here. My only solution is x equals 0. That concludes this lesson for Educator.com. See you soon.